So this is 9.1. We want to graph these with using the quadratic equation. In this situation, we just have a bunch of vocab words. So when you have something like this, we can use our calculator and do y equals. You could also use your phone calculator for this. Negative x, make sure you use this x here. And then squared minus 6x minus 7 and hit graph. That's going to give us a little picture like this. Let's just make a sketch for now. Okay, and I want to just label a few things on here. This is what we call the vertex. The axis of symmetry kind of splits that in half. Symmetry. So like we have an axis of symmetry going here because like the left side is the same as the right side, like it's reflected over. So you have an axis of symmetry. Is it a min or max? This would be a max on this one. And then we'll go through and talk about some of these other things. I just wanted to give you a little picture here of what we have going on. Okay, so let's graph a picture like this and then state the domain and range of this function. State the domain and range. So if I have this situation, we'll go ahead and type this in. Y equals x squared. So it would be x squared minus 4x plus 1. And graph it. Okay, we want to go to second table. It's going to give us some ordered pairs. I like to, when you're looking at this, try to see if you can find like the pattern. So I have a 1, negative 2, 3, negative 2, 1. See how it's like repeating there? Negative 2, 3, negative 2. Those repeating numbers are helpful for us. So we can do 0, 1, 1, negative 2, 2, negative 3, 3, negative 2, 4, and 1. Okay, I'm not super picky about this. We'll do 1. That's probably good. So 0, 1. Whoops, 0, 1's right here. 1, negative 2, 2, negative 1, 2, 3, 3, 1, 2, 3, negative 2, 1, 2, and then 4, 1. Okay, as you graph this, we have a parabola that looks like this. They want to know the domain and range. Domain for these is always all real numbers because we can always plug in anything we want for x. It could be positive, negative, decimal fraction, anything like that. The range will be either y is greater than or equal to or y is less than or equal to your box number. When it opens up, this is when it opens down. Okay. In this case, it's the 1 that's going to go here. This one opens up. So what that's saying is that my whole graph is above this point right here where my y is. Oh, I'm sorry, that's not the right range number that we want. Sorry guys, this ordered pair right here at my vertex is what you want. It's negative 3, so ignore that. So sorry. It's the vertex part of the y. So this is my vertex. So it'd be negative 3. So y is greater than or equal to negative 3. We will get to that more in another problem. Okay, let's try the next one. Y equals 1/2. So 1 divided by 2x squared plus 3. Graph it. Second table, same thing. Let's find our repeating values. Yeah, we might have to go up a little bit. So I've got my 3.5, 3, 3.5. That's where it's repeating. So we'll do negative 2, 5. Negative 1, 3.5, 0, 3, 1, 3.5, 2, and 5. That works for me. So -2 up 1, 2, 3, 4, 5. -1 up 1, 2, 3.5. 0, 1, 2, 3. 1 up to 3.5. And 2 up to 5. So this one's a little wider. Okay, here's my vertex. This was the ordered pair 0, 3. My domain is all real numbers. My range, this is opening up, so it's a greater than or equal to 3. That's the number that's going to go here. All right, thanks for hanging in there. Good job. Next set of examples. We want to find the vertex, the equation of the axis of symmetry, the y-intercept, and the zeros. So my vertex is right here. This looks like I'm going over 1, 2, 3. So 3, -4. The axis of symmetry is always where the x is. So it's x equals 3. It's a vertical line going through the vertex. So if your nose is like your vertex, okay, it's a vertical line going through your nose, okay? That is what this is like, x equals. It will always be x equals box. The y-intercept is where it crosses the y-axis right here. So that's the ordered pair 0, 5. My zeros, we haven't talked about this yet. This is where it crosses the x-axis. So here at 1, 0 and 5, 0. There's 2 of them. So this is the ordered pair 1, 0 and 5, 0. Okay, I know this is a lot of points and stuff to take in. If you got to pause and rewind, go ahead. No worries. Okay, you'll get the hang of it. This one, my vertex is here at the top. Looks like it's on 0, 4. Axis of symmetry is x equals, it's going to be a 0 that time. Number 0 and y. My y-intercept, it also happens to be the vertex. Interesting, that's a special case. The zeros are at -2 and 2, so -2, 0 and 2, 0. We're halfway there. Good job. On the back, we want to use this equation to find the following information. So we got to figure out, is this a max or a min? What the vertex is, and then our other pieces here. So I just like to type this in. Y equals 2x squared plus 4x plus 1. Okay, is it a max or a min? Well, this is opening up, so you could make yourself a little note here. This is a min. This would be a max. It's at the top. So this is a min. The vertex here, okay, instead of going to the table, I'll teach you guys this trick. You can go to second calc or trace. Second trace. This is a min, so select minimum. And then it says left bound question mark, and we can use your left and right arrows, your little spidey guy, move him to the left of the vertex. Hit entry, that's my left boundary. Move it to the right, hit enter. And then it says guess. So then we'd hit guess. And it tells me my minimum is -1, -1. That's kind of nice. So -1, -1. Axis of symmetry starts out as x equals box. That's my x and y here. The y-intercept on this graph, I mean, we don't want to look too closely. You can also go to second calc. Up here we did max and min. This would be value. And we type in when x is 0. So this gives me 0, 1. It's the fast way to do it. Same thing on number 6. Y equals, type in -x squared minus x plus 1. Graph it. That is a max. My vertex, again, I'll show you. Second trace. This one's a max, so we click maximum. Our spidey guy needs to be to the left, so it's a left bound. Hit enter. Spidey guy now needs to go to the right of the vertex. Hit enter. It says guess, so hit enter one more time, and that gives me 0.5 and negative 0.5 and 1.25. That's my vertex this time. Axis of symmetry, x equals box. My y-intercept, again, second trace, value 0, and it tells me it's 0, 1. On my calculator here, 0, 1. Cool stuff, huh? I like it. Okay, last example, then we're done. A graph has a vertex at 4, 0. Over 4, up 0. 1 point on the graph is negative 1, 3. Negative 1, up 1, 2, 3. What is another point on the graph? I think this might be like a bonus one, or it's on your test. Okay, this is my vertex, so I know I'm going to have a parabola, something kind of like this. They want to know what's this point reflected over here. Here's what you know. The distance from here to here is, we know, 1, 2, 3, 4, 5 hops. I went from negative 1 to 3 is 5 moves. Or negative 1 to 4, sorry. So this really is like 4 minus negative 1, which gave me 5. So now I could do 4 plus 5 is 9. If I am at the 4 and I move 5 more this way, so this is 4, 0. I'm going to add 5 more. This would be the point. 9, comma, I'm at 3. That'll make your brain hurt, doesn't it? All right, that is it, my friends. Good work, and way to go.